I think we're streaming right now. Welcome to you YouTube people that sit on inner tubes and exist in YouTube. Notice I didn't say the YouTube, because you can't exist in the YouTube. Right, Nathan? We already had this discussion.
That's correct.
Nathan, where is everybody today? There's more and more people, empty spots here. They were in A-Push? Oh, yeah, that's right. Thank you. Yeah. Now I remember. Okay. All right, did we have an integral here? And we had to have two integrals, is that correct? And did it look like this? Just as a review. 0 to 0.382 r of x minus t of x dx plus the integral of 0.382 to 2.618, I think. And it was u of x minus t of x. Something like that, dx. Am I right on that? And we came up with 1.863. Is that right? Or no? 1.864?
Well, you said both of them.
Both. Okay. I'm just going to write that up there. But then did we do this integral? Did we talk about how we got it? So we have a rectangle that's right here. It's dy thick. And Jake, you'll see me do that every time. Okay? And that reminds me that it has to be in terms of y. And so I wrote this, I think, like y equals a negative x plus 2. And I came up with x equals 2 minus y. Is that correct? Okay. And so this sometimes is called f of y, by the way, equals 2 minus y. And it's basically saying to figure out x, you would have to input y. Y now becomes my independent variable. X becomes my dependent variable. And then over here, I think I did this. Y equals plus or minus the square root of x plus 1, right? I combined those two equations. And then I had y minus 1 squared equals x, right? So another way you can see this is y minus 1 squared equals g of y. So again, it's some function where I'm going to input my y to get my x. Am I okay with that? Or Cooper, am I confusing on that? All right. So did I create the integral? One of the things I'm going to take a look at, I don't know if I did a good job, the ordered pair right there I have as 2.618 comma negative 0.618. And up here I have this ordered pair to be 0.382 comma 1.618. And I don't know if I had done that before or not. And the reason I'm doing that, you remember on the TI that when you figure out the integral, it figures out the area, it draws the little segments all the way across. Do you guys know what I mean? So if you could do that on your calculator, it would look like this. It would start at the bottom and rise towards the top. So the last few would be over there. Are we okay with that? So if I'm going to create my integral, my right numbers, notice on my x-axis, the numbers to the right are always bigger than the numbers to the left. Just like on the top, the numbers on the y-axis to the top are always bigger than the numbers that are to the bottom. So we're going to have right minus left, so it's going to be 2 minus y, and if you want to put in parentheses, you can, you don't have to, minus the right side, which is y minus 1, the quantity squared dy. So here's the right function. Here's the left function. Now, what does a and b have to be? Well, since it's starting here and moving up, and everything has to be in terms of y, I'm going to use the y coordinates, not the x coordinates. So I'm going to integrate from a negative 0.618, which is my y value, to the uppermost value, which was 1.618. And if I integrate this and do it correctly, Jack Luukkonen, what should my area be?
The same.
Should be the same, because the thing didn't change, did it? It's the same shape. So it's going to be, and bounded by the same functions, correct? Just different names. So I should have 1.863. Now the question is how you do that in your calculator. Logan, your calculator does not know the difference between x and y. So to do this on your calculator, it's going to look like this. It's just a variable. It's just a location. It's going to look like this on your calculator. Instead of y, you're going to write x. And so, you'll need your x with your dx. But you're also going to integrate from a negative 6.18 to 1.618, and it'll give you the correct answer. Somebody said on their calculator they were able to integrate in terms of y. I have no idea how to do that. Some people are doing it on your calculators. Did you do it? Well, did you get the same answer? All right. Some important points. First of all, if you have vertical rectangles, these segments I've been drawing, first of all, it's in terms of x. It's dx thick. Your integral will be from a to b of f of x minus g of x dx, which is right minus left. If you have horizontal rectangles, you're going to be in terms of y. In other words, it's dy thick, and it's going to look like this. F of y minus g of y dy, and it's going to be top minus bottom. I'll raise that up a little bit. There we go. While you're writing that down, I'm going to fill out my pen here. Yes.
Where do you get a pen like that?
I got it as a gift. Otherwise, where do you get everything?
Walmart.
The abyss. I suppose Walmart's kind of like the abyss, because I've walked into Walmart maybe 3 times, and I know I'm being recorded, but I don't care. For me, it's a scary experience. First thing, there's a person at the door that's saying hello to me. That's weird, don't you think? Hi. Okay. This is a big store. And then when I go there and I say, all right, I want window markers. What are those? They're markers that you can mark on windows. They don't know where they are. That never happens at Target. They know where stuff is. All right, now I included these problems because usually students have struggled with these, and a lot of it is what does the graph look like? So I'm going to go through and break it down on how you can figure out how to draw these. And some of these I'm going to give you some in which to give you an idea of what type you'll do by hand and what type you'll use as a calculator. This is a typo right here. This should be 2x. So your equation is y equals x squared plus 2x. So these are the two most important parts right here, this x equals 0 and x equals 1. So x equals 0 is the y-axis. And x equals 1 is this vertical line. So I'm going to rewrite. So I'm going to graph this one. Jack, what kind of graph is this?
Quadratic.
Okay, it's a parabola. Okay, and I'm going to start at 0 because it says I'm bounded by these two vertical lines, x equals 0 and x equals 1. So I'm going to start at 0. And when I plug in 0, what's y going to be?
0.
0. So I got this spot right here, and it's going to be a curve, and it's going up, right? And if I plug 1 in here, because that'll be my ending spot, where will I be at?
3.
3. So my graph looks something like that. It's curved. My point is 1, 3. Jack, the next one is this equation right here. Y equals a negative x. What does that graph look like?
It's linear, like that.
So it's like a line at a 45-degree angle?
Yeah.
Okay. So again, this point is 0, 0. What would this point be?
1, negative 1.
1, negative 1. So there's my vertical rectangle. Zach, how thick is it?
1.
It's pretty skinny to be 1. There's another one.
Oh, dx.
It's dx thick. So that means everything has to be in terms of x. So I'm going to integrate. So it's going to be top minus bottom. Correct? All right, so what's the top?
X squared plus 2x.
X squared plus 2x minus, what's the bottom?
Negative x.
Negative x dx. So I could rewrite that as x squared plus 3x. Would you agree?
Yep.
All right. So Logan, I got to have A and B. So they're going to start way over here, correct? And they're going to end way over to the right, correct? What am I integrating from?
Points for the intersection.
Yep. So from here to what?
So 1.
1. I'm going to integrate from 0 to 1. Are we okay with that? Okay, Jake, can you give me the antiderivative?
Would be 1/3 x cubed plus 3/2 x squared.
Perfect.
Plus, or no,
Well, it doesn't have a c
Yeah.
because it's a definite integral and it's going to go from 0 to 1. So if I put 1 in there, I'll get 1/3 plus 3/2. And if I put 0 in there, I get 0. So the question is what is 1/3 and 3/2? Jake, what's the Jacob Schlo? What's the common denominator?
6.
6. So I got 3/6. No, I don't. I have 2/6. I have 2/6 plus what's this going to be, Jake? 9 what? 9/6. So I get 11/6 is my answer, right? And since it's not a word problem, Nathan, there's no units to write. Okay, Nathan, since you brought it up, what kind of graph is this? This would be a parabola. What do you know about the parabola?
It's curved.
Yes, it is curved. Does it go up or down? Okay. What's the y-intercept? You put 0 in for x, what would you get? 2. So it goes like this. Okay. And Nathan, what does the graph g of x equals x look like?
Diagonal line where x's are equal to y's.
Okay, so it's like a 45-degree angle, would you guess? So my area, it looks like something like this. And I'm going to color. I've told you my failed coloring story, right? There's a lot of failures in my life. Failure to dance, failure to color, failure to sing, failure to weld. Not good. Logan, kind of sad, isn't it? Logan, here's one of my rectangles. Are you okay that I shaded in that area, by the way? Okay, so how wide is that rectangle? Dx. So let's start setting up the integral to figure out the area. What minus what?
2 minus x squared minus x.
Perfect. Dx, correct?
Yeah.
How are we gonna, now this is a non-calculator problem. So how are we going to figure out those intersections? They have the same x and the same y, right? The only two places where they have the same x and the same y, right? What we do is we set them equal to each other to figure out what the x is. You remember doing something like that? And what I'm going to do is make this equal to 0 because it's a quadratic, and I get x squared plus x minus 2. So since this is a calculator-free one, it's got to be factorable. Logan, can you factor that?
X minus,
X minus 1, you said?
yeah, minus 1 and then x plus
2. So here x is equal to 1, and here x is equal to a negative 2. Would you agree?
yeah.
Okay, on this integral, where does a negative 2 go?
Bottom.
Okay, because that's the smallest number, and this goes on top. All right, Riley, give me the antiderivative.
2x minus 1/3 x cubed minus 1/2 x squared.
Minus, oops, you're right. I don't know where I wrote that minus. From negative 2 to 1, correct? So if I put 1 in here, I get 2x minus 1/3 minus a half minus, if I put a negative 2 in there, I get a negative 4. A negative 2 cubed is a negative 8, so I get plus 8/3. And if I put a negative 2 into here, it becomes 4. 1/2 of 4 is 2.
It's supposed to be 2, right? Not 2x.
This right here is supposed to be 2x.
Nope.
Right below it.
I think you wrote 2x instead of 2.
Oh, yeah. Oh, why did I write that, Riley? That was crazy. Alrighty, so this is how I would solve this without a calculator. I would do this. I'd have 2 minus 1/3, because I know everybody's afraid of fractions, minus a half, plus 4, minus 8/3, plus 2. Would everybody agree with that part? Loganak, 2 plus 4 plus 2.
8.
8. Perfect. A negative 1/3 minus 8/3. You're right. A negative 9/3 is perfect. Minus 3. So this, and this are gone. Minus a half. What's 8 minus 3? Minus a half. Perfect. 4 1/2. Awesome. Oh, we got sine and cosine. Find the area of one region formed by the intersections of f of x equals the sine of x. Trig, it's enough to make you mad. So here's sine. Here's cosine.
Did you move your paper?
This way? Does that work? So I'm looking at this part right here. So Logan Stockinger, you know how I made them equal to each other right here? Do you see this up here? So I'm going to do the same thing here. I'm going to have the sine of x equal the cosine of x. Raymond, how do I solve that? Did you get a haircut? Oh, okay.
Inverse derivative.
Oh, I want, that's way too much work. Not sure? Noel? Oh, I can't ask you. I already asked you. Cooper? Jack?
Could you just guess and check?
You could. Okay, you could. What would you guess at? That's not a bad way. You know, people laugh. I do that all the time.
Pi over 4.
Pi over 4. Why? What's the sine of pi over 4?
Square root of 2 over 2.
What's the cosine?
Square root of 2 over 2.
Okay, pi over 4 is one answer. Very good. Okay, so my guess is right here. That's pi over 4. Would you guess that correct? Okay. So what's the other one? Now notice what you guys can't see it, and you out in the abyss can't see it. But he took his hand, went like this. Right? That was really good. I do that in my brain because my hands are worthless now. Okay. So what did you get when you did that? 5 pi over 4. That's a pretty good check and guess. You want to know how I do it? Because I never think about it that way. I divide by cosine. So I get the tangent of x is equal to 1, right? Everybody with me on that? The only place where the tangent is equal to 1 is pi over 4 and 5 pi over 4. But your way works just as good, all right? So since you're on a roll, let's set up the integral, okay? What am I integrating from?
Negative 1 to 1.
No. Right here is
Oh,
5 pi over 4. What?
Pi over 4, 5 pi over 4.
Just like when Logan solved that, came up with over here 1 and a negative 2, then we integrated from those, correct? Okay. What minus what? Cosine is this one because it starts at 1.
And sine of x.
And sine is this one because it starts at 0. So what is it?
Would be sine of x minus cosine x.
Dx. Perfect. Are you tired? Okay. So what's, I was just going to give you a break, but if you're not tired, okay. What's the antiderivative of sine?
That'd be negative cosine.
You're doing really good. Negative cosine minus, what's the antiderivative of cosine?
Negative sine. No.
sine. And pi over 4, 5 pi over 4. So I got the negative cosine of 5 pi over 4 minus the sine of 5 pi over 4, parentheses, minus the cosine of pi over 4 minus the sine of pi over 4. Would you agree with that? Okay. So what is the cosine of pi over 4, you said? Yes.
For the second one, you need a negative the cosine, first cosine, right?
For this?
The second part.
Second
The second part
parentheses.
of the second parenthesis, yeah.
Right here, this should be negative.
Yes.
Yes. Okay.
That would be that.
Perfect. So what is the cosine of 5 pi over 4?
Negative square root of 2 over 2.
And since this is a negative, it's going to make it.
Square root of 2 over 2.
So you said this was negative, correct?
Yeah.
So this will be a plus. Would you agree with that? Minus. What's this going to be?
Negative square root of 2 over 2.
Okay. Minus square root of 2 over 2. Would you agree? So I have square root of 2 over 2 plus the square root of 2 over 2 is what? 2 square root of 2 over 2. A lot of 2's. Or a half a square root of 2 plus another half a square root of 2 is how much? A half a square root of 2, right?
Yeah.
Plus another half of the square root of 2,
Square root of 2.
square root of 2. So I got the square root of 2 minus the negative square root of 2. Would you agree? What does that give me?
2 square root of 2.
Perfect. All right, a number 4. I want you to graph it and tell me what it looks like. Need a calculator, Jack?
Oh,
Do you need a calculator, Jack?
no.
Okay.
I have one.
You have one? Can you take it out and graph it?
Sorry, it's a template.
So you should have got something that looks like this. Something like that. It's poorly drawn, but it gives you an idea. So that means you actually have two areas you have to figure out. This one and this one. So you're going to have two integrals that you're going to add. This I'm going to call region 1. This I'm going to call region 2. This is region 1 right here. This is region 2 right here. Cole, were you able to graph it?
Yeah.
Did you figure out any intersection points?
No, I didn't do that.
Okay. Maria, did you figure out any intersection points? Are you able to figure out any intersection points? No? Do you have a graph? What kind of calculator do you have? I don't know what that is. So you got to go to sec. Okay. Right here's a negative. You know the point totally? Negative 2 what?
Yeah.
Negative 2 comma what?
-8. And then 0, 0.
0, 0. And this one?
2, 0.
2, 0. Thank you. Alrighty, so our first integral will be what, Destiny? That's this, number 1.
So it would be
And remember, it's in terms of that.
0.
Negative 2 to 0, perfect. What equation is on first?
It would be 3x cubed minus x.
Okay, so I'm going to call it f of x.
Perfect.
Well, you can have it, you can say it just the way you said it, that's fine. Minus g of x dx. Okay? And then what, so that'll give me region 1. What's region 2?
0 to 2.
0 to 2. And it would be?
F of x minus g of x. dx.
I didn't hear you. So here you have this graph, right? Right, that one right there.
Oh, so it'd be g of x minus f of x.
Yeah, they switched places, didn't they? Okay, so you can use your calculator on this one. So if this is y1 and if this is y2, like I told second period, because I forget stuff so easily, on a test I'll write this, f of x equals y1, g of x equals y2. And when I do that, that's just a note to myself. It's not part of the homework. AP will ignore it. But when I go through it on my calculator and use my calculator, I know I'm going to have y1 minus y2, and over here I'm going to have y2 minus y1. Does that make sense to everybody? Because sometimes I forget. So go through and figure that out. Did we get 27, Jack Lukanen? Huh? It's my favorite number. It's 3 cubed. No? Do we get 9? Because 3 plus 3 plus 3 is 9. Do we get anything with a 3 in it?
3 times 8.
Oh, we got 24?
Yeah.
Is that what we got for an answer? Is 24. Am I going too fast? Okay, you want me to give you more time? Okay, I will slow down. I'll do it on a TI, okay? You want me to do it on a TI?
Well, I have a question on Casio.
I will do it on a Casio. I have 3 calculators up here.
After you do
What's the third one?
dy, the integral y1 minus y2, and then the comma, what do you put after?
Negative 2, comma 1, parenthesis,
Wait, y1?
Yeah.
because you're integrating from a negative 2 to 1.
No, that's your 1 first.
Which one are you doing?
No, there's no 1. That's.
Oh, from negative 2 to 0. Sorry, from negative 2 to 0.
I got 12.
Yeah, you're going to need 2 integrals. My guess is maybe both of them are 12. Are they?
So it would be y2 minus y1.
Yes. Jack.
How come the area under the x-axis is negative?
Okay. It is because you're taking and subtracting this area minus this area.
Yeah, yeah,
That's what you're doing. Does that make sense now?
yeah.
Okay. So I could actually split this up, correct? As 2 separate. I know that this area is negative, correct? And this area is positive, correct? But since I'm having a positive minus a negative, my result will be positive. Okay, that's a great question. You will never get a negative answer or 0, and if you do, you made a mistake. Did it work out for you?
Yep.
All right. So let's take a look at this one. Does anybody know what these look like? They're in terms of y. What do you think this is? It's a sideways parabola, correct? Which way is it going? Left, correct? Okay. So when y is 0, x is 4, correct? When y is 0, x is 4, correct? So 1, 2, 3, 4. And it's a parabola going like this. What is this? It's a line, correct? It's not going to be vertical because it's this, right? Right? That's what that means. So what you could do is do this for a short period of time. So as a y-intercept of 2 and a slope of 1, correct? So there's my graph. And I'm looking at this right in here. Now, you could figure that out vertically, but do you see that you would have 2 integrals? Because this function vertically is different than this function. Do you see why horizontally it's better to start here and work your way up? Would you agree? This point right here is 0, 2. This point right here is going to be 4 minus y squared equals y minus 2, which means 0 equals y squared plus y minus 6. Which means this is factorable. Y plus 3, y minus 2. Which one? So this means y equals a negative 3. This means y equals 2. So which y is that going to be, do you think? Negative 3. In fact, it's a negative 3 comma negative 5, I believe. If I put a negative 3 in here, do I get a negative 5? So my integral looks like what, Emily Koth?
Four minus y squared minus y minus 2.
Like that? What about this?
Negative 3 to 2.
I didn't hear negative 3 to what? 2. Okay. So we'll do this one by hand. And I get 4 minus y squared minus y plus 2 dy. And I get a negative y squared minus y plus 6 dy. Nathan, does that look correct? No? Did I go too fast? I did, I'm sorry. You see where she gets 4 minus y squared? Do you see where she gets a minus y minus 2? Do you see how I distributed the negative sign? Do you see how I had 4 plus 2 and successfully got 6? Then we'll leave the antiderivative.
Negative 1/3 y to the third minus 1/2 y squared plus 6y.
Evaluate it from a negative 3 to 2. So pick somebody. And it can't be me. Who? Logan. Put a 2 in each of these and tell me what you get. So if I put a 2 into here, what will I get?
8, negative 8 thirds.
Perfect. Because Logan's going to, Nathan's going to want to know these numbers. Okay? What about here?
Minus 2,
Very good. What about here?
plus 12.
Plus 12. Got those down, Nathan? Okay. I bet he doesn't go as fast as me, that's why. What about when you put a negative 3 in here? Logan.
9.
9, very good. 9. Minus what?
9 halves.
9 halves. And here? 6 times negative 3.
Oh, yeah, that's from that. Yeah, negative 18.
Negative 18. There you go, Nathan. You figured out those numbers for you. What'd you get? Did you figure it out? No. Okay. Would you like somebody to figure one of them out?
They could.
They could. Okay. Who would you like to figure it out?
Logan.
No, Logan. You can't ask Logan again.
Logan.
This Logan. Okay. What's a negative 2 plus 12? 10. What's negative 8 thirds? It's a negative 2 and 2 thirds. So what's 10 minus 2 and 2 thirds?
7 1/3.
Wow, really fast. 7 and 1/3.
I'll make a flat.
Okay. What's 9 minus 18?
9. Or negative 9.
Negative 9. Okay, here's a hard one. What's a negative 9 minus 4 1/2?
Negative 11 1/2.
I get negative 13 1/2.
Probably right.
You think so? Negative 13,
No, yeah, it's negative 13.
which is a negative 27 halves. What'd you say before? Negative, what and a half? Negative 13 and a half? Okay, Nathan, what's 7 minus a negative 13?
It would be positive
20. What is 1/3 minus a negative 1/2?
0.833.
Or 5/6?
Yeah.
Okay. It's not really what'd you say, 0.8533?
0.833.
Yeah, that's not exactly correct.
0.83 repeating.
Yeah, that's still, without saying the word repeating. This is exactly correct. Okay. Alrighty, we're done. What are we supposed to be doing now, Maria?